continuity in ceramics usually strong and hard material. They do not have easily under the stress, but sudden shock usually breaks them. Polymers can have a range of properties, and also it's typically they are not soft and easily stitched to, okay, but tend to return the original shape. But either deform not break under the sudden stress, but they easily return to the shape within the stress is removed. Okay, it's about ceramics. Okay, an example compared to soft drinks contains make from the metal, glass, ceramics, plastic for the soft drinks. Okay, and then metal can easily squashed and stays in squashed do, and then glass bottle when the dropped into high sharply breaks and then stays in the broken. Okay, the plastic bottle easily sparks but does returns to the original shape when the force is removed. Above the in the above figure I mean I shown about the stress strain curves. It has a ceramics, metal, polymers, and then metals also. The each range of behavior will be having a stress strain level. It have a 3 points. One is a yield and ultimate, and then breaking points. Okay, so modulus of rigidity, the ratio of the stress body and the corresponding strain. Okay, it's such as we can call as a bulk modulus, shear modulus, Young's modulus. It's a coefficient of elasticity and coefficient of elastic modulus. The yield point, the point is stress strain curve that indicates the limit of elastic behavior, the beginning of the plastic behavior. Here are we should know about the yield point. It is the starting point of the elastic limit. Okay, so we should know about all those things. Okay, before that. Okay, so starting with the plastic point and elastic point. Okay, so tensile strength. Tensile is the tensile is the measurement of force required to pull something such as rope, wire, and structural beam to the point where it breaks. The tensile strength of the material is the maximum amount of tensile stress. It can take before failure for example of breaking. Okay, there is a three typical definition of tensile strength. Okay, yield strength. The stresses material can withstand without permanent deformation. This is not a sharply defined point. Yield strength is a stress which is called permanent deformation of 0.2% of original dimension. Ultimate strength, the maximum stress a material can withstand. Okay, breaking the stress coordinate on the stress strain curve at the point of aperture. Okay, so tensile strength we can elongate the material, or else we can convert the material the shape long dia to short dia, and then we can see the figures on the screen. So these are about the tensile property. So tensile strength, it has a yield and ultimate fracture. That's stress cornering the point and necking points will be having. So it is a point between the breaking point and then ultimate point. Toughness is the ability to material to absorb the energy and plastically deform without fracture. When the direction of a material toughness is the amount of energy per unit volume that material can absorb by rupture. Okay, I repeat again. It's a ability of material to absorb energy and plastically deform without fracture. So we can have some stress strain curve diagram in the screen. So for the toughness, the material toughness is the amount of energy per unit volume that material can absorb before rupture. Okay, this is about toughness. And then elongation and plastic deformation. So elongation, plastic deformation. Elongation is a measure of ductility of material determined by the tension test. It is the increase of gauge length of the test specimen after fracture divided by the original gauge length. Higher elongation means higher ductility. Plastic deformation of the cutting edge occurs when the tool material softens high temperature and begins to flow under the pressure of cutting forces. The cutting edges made of a tool at a high speed still deform in the inverse proportion to the difference between the temperature at the cutting edge and yield temperature of two material. Okay, so in the screen you can see about some elongation with some molecule picture with of materials. Okay, so first of all you can see the right side of the stress into plastic region, elastic of plastic region, and then before that you can see the strain region. Stress removed, plastic deformation remains. Okay, So this is a thermal property. The thermal property is a material which is related to conductivity heat. Its words, this is the property which exhibited by the material when the heat is passed through the thermal property come under the broader topical border of the topic of the physical property of material. Okay, so you can have a convection, conduction and radiation in the screen. Okay, so in the remaining things we can see in our next video about the environmental degradation, corrosion, oxidation of the material. You can see other mechanical property and then other deformations of the about the material in our next class. Thank you.